All right, welcome back, boys and girls, to a lesson on expected value. This will be a fun lesson. This is actually the only slide that I'm putting up, and then we're going to play some games. Okay? So, expected value is the average outcome that will occur with many trials of an experiment. So, it's like what you expect to happen when you are doing an experiment that involves probability. Okay? So, let's see if we can read this carefully. X1, X2, X3, all the way to the nth X. Those are the values of the outcomes for some trial. The expected value is the first outcome times the probability of that outcome, plus the second outcome times the probability of that outcome, plus all of the outcomes times the probability of their outcomes. So this is probably a little overwhelming for you guys to understand. So like anything else, examples kind of help us understand what the formulas mean. So let's play a coin tossing game, okay? Let's say that the game costs $1 to play, okay? If you toss a head, you win $1. If you toss a tail, you win $0. Everybody understand how the game works? So you have to pay $1 to play. If you toss a head, you win $1. If you toss a tail, you win $0. Would you like to play this game?
No. Yes. No.
Yes.
We got some yeses and nos.
Yeah.
Yes, you are.
You don't lose $1, you just don't gain anything. Right?
If you pay for $1 to start the game, if you get a tail, you lose $1 because you took $1 to
Wait,
spend
but
it.
then
You
if you
spend
pay
$1.
to play and then you
That means if
flip
you get
heads,
heads, you're winning.
something
All right, well, let's
Yeah,
do the
exactly.
math. Let's do the math.
Math.
What's the probability of a head?
50%.
0.5. What's the probability of a tail? 0.5. All right, now, what is your outcome if you get a head?
You win $1.
What plus $1?
What is your outcome if you get a tail?
$0.
$0. What's 0.5 times 1?
0.5.
50 cents. What's 0.5 times 0? 0. Your expected value is 50 cents.
But you pay
And you
$1.
pay $1 to play, so would you play this game?
No.
No.
You would not. What would they need to pay you in order to make this a fair game?
$100.
Well, that wouldn't be fair. That would be
$2.
It would be a $2 payment on the head would make this a fair game. How else could you make it a fair game?
Cost less.
Make the tail $1.
You can make the tail $1, and then now we just got a game that doesn't really involve any risk or any winning. You pay me $1, I'll let you flip a coin, and I'll give you your $1 back. Okay? Does that make sense? All right, now let's look at one that's maybe just a little bit more complicated. Now let's do a spinning wheel. And imagine that this is a real circle with symmetric lines, so every one of these quadrants is exactly the same area. We're taking a spinner and spinning it around, okay? This game costs $10 to play. Okay? A 1 is going to give you $2 back. A 2 is going to give you $4 back. A 3 is going to give you $8 back. Sorry. And a 4 will give you $16 back. 10 to play. I honestly don't know if this is a fair game or not. It seems like it's close, but I'm leaning no.
Yeah, I wouldn't play it.
Okay, let's see what our expected value is. What's the probability that it falls in any one of these quadrants? So it's going to be 0.25 times 2, right? Fill out the rest for me. Plus
0.25 times 4.
0.25 times 4 plus 0.25 times 8 plus,
0.25 times 16.
so you get 50 cents, a dollar, $4, so that's $5.50. Oh, this is so close, isn't it? What's your expected value?
7.5.
Is that all it is? 7? Hold on. 50 cents. Oh, yeah. 4 plus 2 plus 1 plus 0.5. $7.50. Your expected value is $7.50. How much does it cost to play? Would you play?
No.
That's a no.
Something you can see.
Okay. What's up, Nathan? Okay, so hey, what you just kind of took part in is called game theory. Okay, game theory is awesome. It's like certainly one of my favorite parts of math. But actually, probability and statistics came out of game theory. So people started thinking like, oh, we need to numerate these outcomes. We need to know more about whether or not we should do these things. And then that brings me to a great field for your wonderful minds, which is a field called decision science. Like at Miami, their statistics course in business is not called statistics. It's called decision science. What do you think those words mean? Decision science.
It's like
Katie?
the science of how people decide, like make their choices.
That's exactly right. It's the factual system designed to help people make the optimal decisions, specifically within business. So that's kind of why you're learning about this stuff. Make sense? Boom.